So guys, today we're going to be talking we're skipping 3.2, we're going to 3.3, which is slope-intercept form. We're talking about linear functions, and today we're going to be specifically talking about different forms of the way that we can write a linear equation. So today we're going to be talking about slope-intercept form, so you should be on page 38, date, title, and then you should have your little flip book with the slope-intercept form glued into your book. Before we get to that, let's add a couple definitions to our vocab page. So vocab. So we have rate of change and slope. Now remember at the very, very beginning of the year when we talked about function families? Okay, so function families, we had the linear function family, the quadratic function family, the exponential function family, linear piecewise, linear absolute value, and that was it, right? Yeah. Okay. Just like a family, each function family has what is called a parent function. The parent function is the simplest form of the function that we can write. So, for example, in the quadratic, and you don't have to write this down, but just to show you, in the quadratic function family, the parent function would be f of x equals x squared. It's like the simplest we can get, right? For the absolute value function family, the parent function would be f of x equals the absolute value of x. Just the simplest we can get it. So the linear parent function, the definition is a linear equation in its very simplest form. And the linear parent function is f of x equals x. Nothing being multiplied to it, nothing being added to it. So the very simplest form we can get. So if we're looking at a linear function in the graph, we have to be able to have an equation that represents that graph, right? So a linear equation is an equation that models a linear function. One example that I came up with was y equals 1/3 x minus 5. I want you to come up for your example with something different. So it can be anything else, but come up with something different, an example of a linear equation on your own. So what's the linear equation that someone came up with? Aubrey.
2x plus 3.
Y equals 2x plus 3. Is that a linear equation, guys? Yes. Megan.
3x minus 5.
3x minus 5. Does that work?
Yeah.
Yep, Peyton.
1/2 x plus 5.
1/2 x plus 5.
1/4 x minus 6.
1/4 x minus 6. All of those work, Giovanni.
2x plus 2.
2x plus 2 also works.
1/5 x minus 3.
1/5 x minus 3. Good. Okay, so any of those work. They're all linear functions because they all contain just an x. So we're going to talk about, we can write linear equations. This is the most common way that we see it, so that's the form that we're talking about today. There are actually 3 different ways that we can write linear equations in 3 different forms. Today we're talking about the most common, which is slope-intercept form. Now we already know what slope means, so let's define what the intercept in slope-intercept form means. When we're talking about slope-intercept form, I'm specifically talking about the y-intercept. The y-intercept is the y-coordinate of a point where the graph crosses the y-axis. And then I drew a little picture of the graph, and then we will determine what the y-intercept of that one is in just a second. So guys, on this one, the y-intercept is going to be this point right here where the graph is crossing the y-axis. I usually abbreviate it to y-int, but what is that point?
2.
Positive 2. So we would say that the y-intercept is positive 2. So what do you think the point where the graph crosses the x-axis is called? The x-intercept. Okay, we will get there in a couple of days. Today we're just worrying about the y-intercept. Not too bad? Okay, so let's actually then look at slope-intercept form of a line. So I gave you the slope-intercept form. The slope-intercept form is y equals mx plus b. So let's actually identify what each of those pieces means. The y equals, that means your output, what we're going to get out when we plug stuff into the equation. When you are writing an equation in slope-intercept form, this stays y. So that's what I want you to write, stays y. Meaning that there's nothing that we're going to plug in to y that's going to change it from anything but y. Okay, so when we're writing an equation, it stays y. The only time you plug anything in is if you are plugging a point into the equation. Okay? The m, we know what m stands for. What does m stand for? Slope. So the m is your slope. So if the y gets to stay y, do you think the x changes ever? No. The only time, so we're going to write stays x. The only time you plug anything in for x is when you are plugging in a point. And there will be an example where we do that, but when we're just writing the equation out, it stays as an x. Okay? Is the x part of the slope? No, the slope is just m. Okay, the x means your x coordinate. Okay, so if m is the slope, x and y get to stay x and y, what do you think b represents? If this is slope-intercept form, it's the y-intercept. Okay, so b is your y-intercept. So that's all the pieces. The example in the back, we're going to come to that in just a second, but first we're going to practice just using the formula. Okay, so example 1, just write it right underneath. I'm going to have you identify the slope and y-intercept of this equation. Y equals 5x minus 2. Okay, guys, so this is in slope-intercept form because it looks like y equals mx plus b. So we're just going to identify the parts. So my m is my slope, which is the number right in front of x. So that is going to be my slope. So my slope is what? 5. Just the 5. It's not 5x. X is your x coordinate, so it is not the x. Just the 5. This number right here is negative 2. That's where my b is. So that's going to be my y-intercept. But it's negative. So my y-intercept is going to be what? Negative 2. So for the next one, I'm going to actually give you a slope and a y-intercept, and we're going to write the equation of the line. So that's example 2. Write an equation with slope negative 4 over 5 and y-intercept 7. All right, guys, so we're basically just going to take these pieces and plug them into the slope-intercept form. So it starts with y equals m. What's m? Negative 4 over 5. X gets to stay x plus b, which is positive 7. There's your equation. Yep. So in the example that goes with your little flip book, now I give you a graph and I want you to write the equation of the line. Okay? So before we even start, we need to identify the slope and the y-intercept. So right on top, I'm going to write slope equals and y-intercept equals, and then we'll actually plug everything in. Okay, the y-intercept has to be the first point that we find, which is where it crosses the graph. So what is the y-intercept there? 1. So I'm going to label it 2. Y-intercept. Okay, in order to find my slope, I need to pick another point on the graph. I'm going to pick this one right here, 3, 0, just because it's easy to find. So my slope is rise over run. So I'm going to start up here and I'm going to go down. So if I'm going down, what's my rise? Negative 1 over, what is my run? Positive 3. If I had gone the other way and went up 1 and left 3, would I still have got negative 1/3? Yeah. Okay. So my run was 3, my rise was negative 1. Okay. So now let's plug everything into slope-intercept form. Y equals m. What's m? Slope, which is negative 1/3. X plus b,
1.
plus 1.
I feel like this is one of those commercials.
The hardest type of question we're going to see is when I don't give you the slope, but I give you 2 points. So next one I'm going to do is give you 2 points on the graph, and I want you to write the equation. Okay, so I'll give you a second to write this down, and I want you to write all of the problems, but you are going to, second to last. We're going to write the equation of a line that passes through the points 2, 1, and 5, negative 8. Okay, so for this problem, I don't know what the slope is, and it doesn't tell me what the y-intercept is. But I do have 2 points. I do not want to graph this because that takes way too much time. But can I find some stuff using just 2 points? Yesterday we worked on it. Can you find the slope using just 2 points?
Yeah.
Yeah, so let's use the slope formula first. Remember, m equals y2 minus y1 over x2 minus x1. So it has to be the y's over the x's. Which point do you guys want to make x1, y1? 2, 1. Okay, so I'm going to label it x1, y1. So that makes 5, negative 8, x2, y2. And then we just plug everything in. So that's going to be negative 8 minus 1 over 5 minus 2. Okay, guys, what's negative 8 minus 1? Negative 9 over 3. And does that reduce at all?
Yeah.
Yes, that reduces to negative 3. Okay, so I have my slope. I still don't have my y-intercept, and I have no idea how to find it. What else do I have, though? I have my slope, and I have 2 points. Is this an x and a y? Is that an x and a y? So what we can do is we can pick either of these 2 points. It actually does not matter which one you pick. We can plug those into x and y. We can plug in our slope, and then we can solve for b. Watch. Which one looks easier to work with? Okay, so it's y equals mx plus b. Which point is the 1? Which one is the y? 1. So that's going to be 1 equals m, which is negative 3, times x. What's the x? 2, plus b. So I plugged in a y and an x that was given to me that I know are on the line because they told me they were. If you use 5, negative 8, you would get the exact same answer. And then we just solve for b. So 1 equals negative 6 plus b. Add 6 to both sides. So we get b equals 7. If I plugged in 5, negative 8, I still would have got b equals 7 because all these points lie on the exact same line. So now I have my b and I have my m, and I can rewrite the whole thing as a slope-intercept form. So that's y equals negative 3x plus 7. And there's your equation. Okay? So the only time you can plug anything in for y and x are if you are plugging in a point, but then when we rewrite it in slope-intercept form, they go back to y and x. Okay? And that's because I know that 2, 1 lies on the line. I know that 5, negative 8 lies on the line. So since they both lie on the same line, they're going to give me the same y-intercept. Okay? Okay, last one. I'm going to give you the equation of the line, and I want you to graph it. So we are going to graph y equals negative 2/3 x plus 1, and then I just drew a small x and y axis. This kind of problem where they give me the equation and then I have to graph it is just going backwards of giving you the graph and writing the equation. So let's take a look and label the different parts first. Before we even start, which number represents my slope? Negative 2/3. So this is my slope. I'm going to label it. Now, It's negative 2/3. Could I attach the negative to the 2, or do I want to attach it to the 3? Doesn't matter.
No.
Doesn't matter. I can attach it to either the 2 or the 3, okay? I usually just attach it to the top. So, negative 2 is going to be my rise, and I'm going to have positive 3 be my run. You cannot make both negative. Only one can be negative. And then what's my y-intercept? Positive 1. So how do we graph this? We start with the y-intercept at positive 1. So on the y-axis, I'm going to put a point at positive 1. And then from that point, I'm going to count my slope. My rise is negative 2. So from this point, I'm going to go down 1, 2. And if my run is positive 3, which direction am I going?
Right.
Right. So 1, 2, 3. Connect the points.
What is that supposed to be?
Wait.
That's really got it.
Okay. That is slope-intercept form. So we'll work with this a little bit more tomorrow. Tomorrow we'll do the left-hand page, so don't worry about that. Make sure you have the homework written down, though.